we go over inverse trig derivatives. So say we've been given y is equal to sine inverse of x. How do we find the derivative of this one? And so if we have got something that is like this, we can introduce sine on both sides, and so we're going to have sine y is equal to x. Why is it like this? If we introduce sine this side and introduce sine that side, sine and sine inverse, they are going to cancel out, and so we're just going to remain with x there. Now at this point, we can find the derivative of this implicitly, okay, using implicit differentiation. So now let's go with it. So what we want to take is now the derivative of everything that we have here. We know that the derivative of sine is what? Is cosine. Now we are finding the derivative of sine y, and so this which is here is going to come there, and we are going to write it as cosine. We have differentiated sine y so that to give us cosine y, but as long as we've differentiated sine y, we also need to put dy over dx. We need to show which one we've differentiated. We've differentiated y with respect to what? To x. And then over the other side, what are we differentiating? We're differentiating x. The derivative of x is 1. So we're also going to show d. Now at this point, what have we differentiated? It's x with respect to what? To x. Now dx over dx is a 1. So you see that this we don't show it. Okay. So that will be it. And so now what we are going to do is we want to remain with dy over dx. So we're going to divide by cos y. So that will give us dy over dx is equal to 1 over cos y. Well, from this we know that sine squared y plus cos squared y is equal to 1. And so using this, we can take sine the other side, and so that is going to give us cos squared y is equal to 1 minus sine squared y. Now at this point we can square root both sides, and so that is going to give us y is equal to, cos y being equal to the square root of 1 minus sine squared y. So that is what we have. And then we are going to go back to what we have at this point. Where there is cos y, we are going to put the square root of 1 minus sine squared y in that manner. And so we know that from the point which we have here, okay, we are talking of 1 minus sine squared y. Now let's consider sine y. What is sine y giving us? This sine y is giving us x. Sine y is equal to x. So where there is sine y, we are going to put x. Of course, if we have got sine squared y, this can also be written as sine y, and then we put a squared outside. So where there is sine y, we are going to put x, and so this is going to give us 1 over 1 minus x, but that is squared, square root. So this is the derivative of the inverse of sine. Now using the same way, let's determine the derivative of the inverse of cosine. So say we've got y is equal to cosine inverse of x. So if we introduce cosine on both sides, we're going to see that cosine y is going to give us what? X. So differentiating this also implicitly, d over dx of everything we have here is going to give us cos, if we differentiate cos y, we are supposed to get negative sin y. Okay, this we know if we have got cosine here, we've got negative cosine here, and then let's put sine x here, and then negative sine x here. So if you move like this, that is showing the derivative. So that means if you move from cos, you differentiate cos, we are going to get negative sine. The derivative of negative sine gives you this. The derivative of negative cos gives you that. The derivative of sine gives you that. Okay. So now that is given us negative sine at this point. Now whenever you differentiate y, you need to put dy over dx. And that is going to be equal to the derivative of x is a 1. Well, we can divide by negative sine y to remain with dy over dx. So dy over dx is going to be equal to, divided by, at this point first we could have just multiplied by a negative 1, so that this negative cancels and then the negative comes here. So we've got negative 1. And then we divide now by sine y. So over sine y. Again, from sine squared y plus cos squared y is equal to 1. We can take cos the other side, and so that will give us sine squared x being equal to 1 minus cos squared. Okay, we are now using x as a y here. Sine squared y is equal to 1 minus cos squared y. I can square root on both sides. That will give me sine y is equal to the square root of 1 minus cos squared y. And so where there is sine y, I can replace that. So that is negative 1 over the square root of 1 minus cos squared y. But what is cos y? From what we can see here, cos y is equal to x. So where there is cos y, I'll put x. So that will give me negative 1 over the root of 1 minus, where there is cos y we put x, but remember that is cos squared y, so that will be squared. So this is the derivative of the cosine inverse. Well, we can use this same way to find the derivative of tan inverse. And how do we go about it? So let's say y is equal to tan inverse of x. This, if we differentiate tan, we introduce first tan on both sides. That is going to give us tan y being equal to what? X. So we're going to find now the derivative implicitly again. So d over dx of tan y. If we differentiate tan y, we're supposed to get sec squared y. But when immediately we differentiate something that has got y, we need to introduce dy over dx. And so the derivative of x is a what? It's a 1. So this is going to give us dy over dx being equal to 1 over sec squared x. Well, at this point, we know that from our identities, sec squared x is equal to 1 plus tan squared x. So, and again, we are differentiating y here. I don't know why I'm using x. Obviously, just being used with using x. So that is a y there. So if you've got sec squared x, that gives you 1 plus tan squared x. These are from identities which we can prove. Okay, so where there is sec squared y, I'll put 1 plus tan squared y. So that will be 1 over 1 plus tan squared y. And so at this point, what we can do is, of course, we know. Let's look at this. Look at this point which is here. X is giving us what? Tan y. So where there is tan y, we are going to replace with x. So that will give us 1 over 1 plus. Where there is tan, we are going to put x, but that is squared. So that will become the derivative of tan inverse. Now, to complete the other derivatives for the opposites of sec, so if you are finding the derivative d over dx of sec inverse of x, this is supposed to give you, okay, this is going to give a 1 divided by the absolute value of x, and then square root x squared minus 1. And then the derivative inverse for sine is cosecant. Okay, so cosec x, if we differentiate this, we're supposed to get negative 1 divided by the absolute value of x, and then we have got x squared minus 1. And then the last one, cot inverse of x. This is supposed to give us negative 1 divided by 1 plus x squared. So we can use the same procedure that we've been using to show these. We can try them out. And so let's look at a simple problem here concerning the derivative of inverse tangent functions. I mean inverse trig functions, not only tangent. So let's say we've been given y is equal to, say, sine inverse of 2x. How do we get to find the derivative of this one? And so all we are going to do is let what we have here, let's say u represent 2x. So that is going to give us y is equal to sine inverse of what? Of u. Well, if we have got this, now we can find the derivative. So we are going to say dy over dx. We know the derivative of sine inverse of u. That is supposed to give us 1 over the square root of 1 minus u squared. This we already showed. But where there is u, we are going to put back our 2x. And so that is going to give us 1 over the square root of 1 minus 2x squared. And we know that this is going to give us what? Okay, that is going to give us back. I've left out something here which we needed to do when we are differentiating. So before we even go to all this way, I forgot to differentiate this portion. We are supposed also to differentiate it. So we are saying dy over dx is going to be a product if we differentiate y with respect to u, and then we differentiate u with respect to x. So it is a product of those. We are not supposed to forget that. So dy over dx is dy over du times du over dx. Now we know that if we differentiate this sine inverse of u, we know that it's supposed to give us 1 over the root of 1 minus u squared. Okay, like that. And then we are multiplying that by, if we differentiate 2x, we're supposed to get a 2. So that is going to give us 2 on top divided by the root of 1 minus. Now we are going to put, where there is u, we are going to put 2x. So that will be 2x squared, which is going to give 4x squared. So this is the derivative for that one. So all we've done is at this point we'll put 2x and then worked it out in that manner. Okay, so basically we can work with so much different problems regarding whatsoever that you can be looking at. Just understanding just these main ones which you've derived, you are able to find the inverse, the derivatives of any other thing that you've been given. So consider if you've been given y is equal to cos inverse of 3x. So again we can just say let u represent the 3x which we have there, and so this will give us y is equal to cosine inverse of what? Of u. So at the point where we have got 3x, we've just put u. So dy over dx is going to be equal to, first we differentiate this which is here, dy with respect to u, and then we differentiate this one here, that is du with respect to x. Now dy over du, we know that if we differentiate cosine inverse of u, we're supposed to get negative 1 over 1 minus u squared. And this we are multiplying by du over dx. If we differentiate 3x, we're supposed to get a 3. So that is going to give us negative 3. Okay, open brackets. Negative 3 divided by let me write it like that. Okay, and then that will be the root of 1 minus, now where there is u, we replace back this, but remember it's squared. 3x squared will give us 9x squared. So basically that will be the derivative of